what happens if it's higher up?
There won't be a reaction.
Yeah, nothing will happen. Okay?
Okay, so like for the hydrochloric acid one, there would be a reaction to zinc. So like would the answer be, because it's not on the chart, so would the answer be because, yeah, like we just did it, that's not how to explain it.
How do you explain it?
So that,
Just the way we explained the other one. Zinc's higher on the activity series than the hydrogen and acid.
one is pretty much kind of like back and forth, same answer.
Pretty much.
So, but is zinc higher than hydrochloric acid?
Zinc is higher than an acidic hydrogen. Look on the activity series. All right.
What do you
Okay. Shh. Put your lab sheet away, please. Put your lab sheet away, please.
Can you like answer this one? Because I'm not going to be able to do it if I don't.
Zinc is higher on the activity series than an acidic hydrogen. Put your lab sheet away, please.
Okay, my last sheet's away, but like, how do you know which ones are the acids also?
Acids have hydrogens on the front of the formula. Acids have hydrogen in the front of the formula.
So like, if these don't have H in front of them, what are you talking about?
Well, then it's not an acid.
Then none of these are acids. How do you...
Are you talking about on the activity series how to tell if it's a hydrogen?
That's what I've been talking about. I know it's
Any
not, but what are you talking about? So when you come with the acids on that paper, you would put the hydrogen.
So any metal that's above right here, that's the hydrogen that's in an acid right there. Hydrogen and acid have an H plus. They're positively charged. So any metal above that will replace a hydrogen and an acid. Okay? That was the demonstration. We did, right?
I know it's just strange how they're explaining it. They don't explain it very well.
Okay. Yes. Yep.
I was just about that.
All right. Now, you have to also, if you have a single replacement reaction and the metal that's by itself is not higher than the metal in the compound, then you're going to simply write NR for no reaction. Okay? Let's look at an example of that. Let's suppose I'm going to react, I don't know, how about zinc nitrate? Okay, I'm going to react zinc nitrate with, or I'm going to put it in the same solution as iron metal. Okay? Let's look at the activity series here. Here's zinc, and iron is right here. So in order for iron to react with the zinc in a compound, in order for iron to displace the zinc in a compound, the iron has to be higher on the activity series. Is iron higher on the activity series? No. So therefore it doesn't displace zinc, and there is no reaction. And that's all you do. I'm not doing any of them. I'm doing another example of single replacement reactions. If there is no driving force, there's no reaction. If the metal is not higher than another metal if the metal is by itself in the reaction or in the equation is not higher on the activity series than the metal in the compound or the hydrogen, then there's no reaction. Nothing happens.
So you never have to put like what you think you'll do, like gold or blood or anything. You just have to say reaction or no reaction.
Yeah. But if you're reacting an active metal, one of these metals, with an acid, then you should know that you should see bubbles there, and you can say that. Yes.
What if, for example, something higher than zinc, it won't react.
No. I mean, you're talking about if zinc is in a well, that's,
Yeah, like,
oh, you mean, okay, so if I was reacting zinc nitrate with aluminum,
I'm talking about like, on the front part, ZN,
are you talking about the lab sheet again?
yeah.
We're done with that right now.
No, I'm
With
just
that,
Then
asking like, as an
how are we
example.
gonna do homework if you don't?
I'm not doing it for
No,
you.
I'm just asking like, as an example, like, for an example.
I just explained that. Iron's not higher, there's no reaction. Okay?
It's like we can't ask questions on the lab thing. We haven't asked questions to be able to do it.
I'm not helping you anymore with the lab sheet in class. Okay?
I'm busy, so I can't come to school and I don't want to do it for homework.
Marissa, it's time to be quiet. Excuse me? Yes. Okay. Now, you also have to be able to predict the products of double replacement reactions. Double replacement reactions. Okay? We're doing something else with double replacement today. Okay? We balanced double replacement reactions yesterday. Today we're predicting the product. Yes? No? Okay. Now, we said with single replacement reactions, there was only one driving force. What was the driving force for a single replacement reaction?
Driving force.
Yeah. The thing that makes the reaction occur.
I don't remember what you said.
The driving force for a single replacement reaction,
Is it the same size?
yes. The driving force for a single replacement reaction is an element that's by itself higher on the activity series than an element that's the driving force rule, if you want to put it that way, okay?
Is that one of the soluble rules?
No, that's not the solubility rules. The driving force for a single replacement reaction, or you have a driving force if an element is higher on the activity, an element that's by itself is higher on the activity series than an element it's like in a compound. You have a driving force for a single replacement reaction if the element that's by itself is higher on the activity series than an element it's like in a compound. Okay? Now, double replacement reactions have a different driving force. Double replacement reactions have a different driving force. So you first have to figure out whether your chemical reaction is single replacement or double replacement or something else. Because you can't apply the driving force for a single replacement reaction to a double replacement reaction. So you first have to figure out what kind of reaction it is. You have to classify it first. Okay? Double replacement reactions have driving forces that are all about the products that are formed. Okay? So if you form a solid, if you form water, or if you form a gas, that's a driving force for a double replacement reaction. Pretty much, yeah. Okay? So for single replacement reactions, it's all about, the driving force is all about the reactants. Pretty much. Okay? For single replacement reactions, it's all about, the driving forces are all about reactants. Does the reactant element that's by itself higher on the activity series than the element in the reactants? It's in the compound. And if it is, it has a driving force. If it's not, it's not. For double replacement reactions, it's all about the product. What are you forming? If you're forming a solid, if you're forming water, or if you're forming a gas, then you've got a driving force. If you don't have a driving force, you've got no reaction. Okay?